All right, good morning, everyone. Can you guys hear me okay?
Yes.
Yes.
Okay,
Yes,
thanks.
yes.
Uh, yeah, so hopefully you guys didn't experience too much power outage this weekend. I know I was out for 2 days, and some of you guys probably experienced that as well, but hopefully we're all back to normal. Hopefully you guys are good on your end. Um, I want to start off by talking about the schedule for this week. Okay. Okay. So today we're going to do test review, chapter 3. There's a couple of printouts or a couple of links on my under today's. I have 2 links under today's. Hopefully, you guys all have that printed out or have access to it. I'm going to be kind of jumping around between different problems, kind of highlighting the ones that I feel are most important for today for us to go over. The test is still going to be on Thursday. Initially, we were going to have 5.1 notes today, but we lost Friday, so we're just going to spend today and Wednesday doing test review, Thursday test, and then we'll start chapter 5 on Friday. Okay. I had a help session this morning at 7:30, and then I'll have one again at 4. Initially, I was thinking I could do 3:30, but I have a meeting at 3:30, so 4 o'clock help session. And again, Wednesday I'll have help sessions 7:30 and 3:30. And this one, Wednesday is going to be on Teams or face-to-face. So, but these will all be recorded. Tomorrow, there's no school, but I do want to talk about the quiz recovery assignment. I'm going to be updating that assignment today on Teams. There are 3 parts to the assignment. The first one is classwork, homework of chapter 3. Second one is assignment problems from the textbook for you to finish. And there's a third part, which is quiz corrections. Now this, I realized I wasn't able to give back your quiz. I was hoping to do it today, but we're all virtual, so I won't be able to give back the quiz to the face-to-face students until Wednesday. So this third part is going to be due on Friday. Okay, due on Friday by midnight. Okay, because you're not going to be able to get to it till Wednesday. So we're going to do a little bit of a departure for this recovery because of the time crunch and because of the fact that, just because of the fact that we lost so many days. So the way this is going to work, but just for this time, is that if you do the recovery assignments, well, at least 2 out of the 3, and turn in by midnight, then you're going to be eligible to replace your quiz grade with the test grade on Thursday if it is better than your quiz grade. So let's say you made an 85 on the quiz and you went through and you turned in the assignments that was needed, at least a portion of it, not the quiz, but the first parts of it, then you're eligible to replace that 85 if you get a higher grade on the test. So let's say you get me a 92 on the test, then if I see that you turn in your assignment on time, I'll replace your 85 with 92. Okay. But I'm only going to replace it if you did the appropriate assignment, you turn it in on time, and you and it's a better grade. Okay, I'm not going to replace it if it's a lower grade. Now the quiz correction portion, you can turn into me by Friday. Either I will make another Teams assignment or you can just email it to me. And this Tuesday afternoon, I'm going to have a help session going over the quiz. I know that this is more, it's not ideal time maybe because for face-to-face students, you guys don't have the quiz in front of you, so you may not know exactly what you missed. But I'll record it. But if you want to still stop by and I'll go over problems similar to the quiz. There are different versions out there, but I think if you understand the steps, then you can, and also it'd be a good review, right? Good review for the test going over these topics. So that's why I'm going to have it tomorrow afternoon at 3. Okay. Then moving on to Wednesday, we have help sessions. We're going to do another day of test review. Test is on Thursday, morning review, face-to-face and on Teams, and then Friday we start our Chapter 5. So any questions about the recovery assignment? Everybody okay?
I don't have any questions.
Okay, no questions. All right. So I do want to kind of give you an idea as to what the test will be like and the focus of the test. So the test is going to be 6 questions. There's going to be 3 free response, kind of extended problems, and we're going to be focusing on those kind of extended, these big topics today in class. So on the test, you'll see a derivative graph problem, which is similar to the one that we're going to be doing in class today. We'll do a curve sketch problem, which is kind of a more traditional problem that you've seen on the quiz, where I give you a function, you find the derivative, you gather your slope sine line, you create your second derivative sine line, and you fill that in, and you identify all that information. And then a third extended longer problem is going to be an optimization problem. And that optimization problem could be one of the types that we've gone over in class. It could be a cost problem. It could be area perimeter problem. It could be a volume surface area problem. It could be a problem where we're folding up the sides, trying to cut corners around the sheet of paper and folding it up to maximize the volume. It could be maximizing a revenue problem, where similar to the hotel problem, where we're raising the rates but we're losing customers and trying to find that balance. So it'll be you'll see one of the problems that we've gone over. Okay, so those are the 3 big problems on the test, and then 4 through 6 will be more quiz topics, like EVT or roles or mean value theorem or first derivative test or second derivative test. Okay. Open notes, and you can get free to use your calculator as well. So yeah, that's the format of the test. Any questions? Okay, so today we're just focusing on these 3 topics. This is the bulk of your points right here. All right. So I have a couple of review sheets here. Let's first start off going to the back page of worksheet 1, and let's look at number 8. We'll start with an optimization problem, and then we'll look at the graphing parts of the test. A manufacturer wants to design an open top box having a square base and surface area of 80 square inches. What dimensions will provide a box with maximum volume? And we're going to find that maximum volume. So we're looking for keywords, right? Keyword here is maximum, and it's describing volume, so we know that is going to be our focus of attention. That's going to be our primary equation. Okay, let me draw the box here. Square base. I know my dimensions will be the same, but I don't know about the height, so I need to give it another variable. Star next to it, that's my focus. Now, I know I need to find the derivative, but I need some help, right? There's too many variables. I need something to break this, get this down to one variable. So the help is going to come from surface area. So if you think about surface area is just adding the areas of each of the surfaces. So surface area, we have area of the base, which is x times x. We have surfaces of the vertical sides. There's 4 of them. And then one vertical side has an area of x times h, so xh. But we have 4 of them, so xh plus xh plus xh plus xh is 4xh. So we have base and 4 vertical sides and nothing for the top because it's open top. We know surface area is 80 square inches. Or sorry, 80 square inches. We want to replace one of the variables. Looks like the easiest variable to replace is h. So I'm going to target solving for h so I can make that replacement. So this is going to get put into the h here. Okay, we're going to update our volume equation. So our first goal is accomplished. We were able to get our equation on the right side to be in terms of just x. So that's a good first start. Now the next step is trying to get this ready for derivative, right? We do want to find the derivative, but the problem that you're gonna see, they're all going to be power rule problems. Okay, so we should not have to deal with any messy rules, no product, no quotient, no chain. So if you're looking at one of those complex rules, that means you didn't go far enough in terms of your cleanup. So we're going to clean this up so that we have just a nice, easy power rule problem for us to find the derivative. So distribute the x squared through. I'm going to expand and separate this out. There's only one term in the denominator. So if I can separate this out, I can treat each term and get each term ready for power rule. So reduce the fraction, cancel out one of the x's. take out one of the x's. I can push that 4 out as 1/4. And now we can find the derivative, right? Now it's a nice, clean problem. Power rule. Okay, we set our derivative equal to 0. And now we want to solve for x. Dividing both sides by 3/4, the same thing as multiplying by 4/3. Take the square root. Clean that up, and we get x equals 5.164. So once we solve for x, right, we always go back and reread the problem and see if we have everything that we need. It's asking for dimensions, so we need to find the height as well. So we can plug x into the height equation, which everything should be already there for us to use. So plug in 5.164 for x, 80 minus 5.164 squared over 4 times 5.164, h equals 2.582 inches. So we have dimensions. We have length, width, and height identified. Now to find the max volume. So basically any volume equation is good. I mean, we can use this original one if you like. We have the height, so we just do 5.164 squared times 2.582. Or you can use any of the adapted volume equation. That's all good. What you don't want to do is you don't want to plug into V prime. So V prime is not going to get you your volume, right? But any of the V equations, they're all going to give you the same thing. Okay. So pick whichever one you want to use. Okay, so I think we've gathered all the information that we need, dimensions and the volume. Volume is 3-dimensional unit, so cubic inches. Okay, any questions there? Okay, let's move on to our other worksheet, which is on that second link under Today, Monday, on my website. And let's do a derivative graph problem. So you'll see a problem like this, very similar. So let's go through each of the steps, make sure you're comfortable with this type of problem. Okay, everybody have this in front of you? Everybody know where to look to find this? Okay, so the first thing to realize is that we're looking at the f-prime graph, which is not the same thing as the f of x graph, which means that these points are not describing the location. So we can't say this is minimum, maximum, relative min, relative max, decrease, increase, decrease, increase, right? This is not the original function. This graph is describing the slope values, not the locations values of the original function. So we have to know how to interpret it. So one thing that I like to do so that I am clear on what I'm looking at and so that I'm not getting kind of gives me a basis is I like to label my graph. I know that what I'm looking at is anything above, location-wise, anything that lands above the x-axis is actually a point where the original graph is going to display a rising slope. Anything below the x-axis are locations where my graph is going to be displaying a negative slope. Anything on the x-axis is where my graph is going to visually give me a slope 0. So we're going to create our slope sign line. I like to include my endpoints, which is from -5 to 5. Pick off my critical points, my slope zeros, -3, -1, and 3. And now let's look at location. You see how all these points are living above the x-axis? So we want all this to be interpreted as positive slope. And you may be wondering, well, looks like negative slope to me. Why is this positive slope? So the reason why is because these are all different y values that represent, these are all like, maybe this is a y value of 3, then a y value of 2, then y value of 1. These all represent different positive slope values. So maybe the slope is different degrees of positive slope. So maybe that's a steeper slope value than here, but these are all going to be representing different degrees of positive slope on the original graph. Okay, from -3 to -1, still above the x-axis, so still representing positive slope. Below the x-axis, that's going to represent location-wise, going to look like negative slope on the original graph. And then from 3 to 5, above the x-axis, so positive slope. So this is helpful because this is how we want our graph to look. Our graph is going to be rising, flattens out, rising, hits a relative max, falls, hits a relative min, and rise again. So based off of this, we can answer parts A through D. Increasing, I have 3 intervals of increasing. Then I have 1 interval of decreasing. And on the test, I will ask you to justify your answer with because statements. So you'll write all these because statements, which you guys did a good job on your quiz. So relative min, because f prime changes from negative to positive. Relative max, because f prime changes from positive to negative. Increasing, because f prime is less than 0. Decreasing, sorry, greater than 0. And then f is decreasing, because f prime is less than 0. Okay, we've gathered all the information that we can from the on the f prime side of things. So now we're going to move on to f double prime, concavity sign line. So again, my second derivative sign line from -5 to 5. But we're going to pick off our critical points a little differently here. Now we want points of inflection to be marked off. So points of inflection are places on the original graph where the graph is at its maximum and minimum steepness, where it's going to be at its steepest. And the way that they're going to be found on the f prime graph are going to be the peaks and valleys of your f prime graph. So point of inflection here. And we're locating the points of inflection of the original graph, right? This is obviously not point of inflection of this graph, but point of inflection of the original graph. Okay, now we can look at the slope pattern of the graph. So we define concave up as where our slope is becoming more positive. So these are slope values becoming more positive. These are wherever there's positive slope is going to translate to concave up on the original graph. Wherever there's negative slope, it's going to translate to concave down on the original graph, because concave down is defined as where the slope is becoming more negative. So I'm going to use a highlighter so we can kind of see things a little bit more clearly here. All the negative slopes, it's going to be where you're going to be experiencing concave down on the original graph. Wherever there's positive slope, it's where we're going to be experiencing concave up. So negative slope, concave down. Positive slope, concave up. And they'll keep alternating, right? All right, any questions here? Okay, so points of inflection. Anywhere we see a change in sign, right? These all have change in signs here. Concave up, 2 intervals here. Concave down, we have 3 intervals. All right, so that's all the information that we can gather from the second derivative sine line. Now we're going to try to put it all together. So we're just going to be relying on the concavity and slope sine line. We're not going to look at this anymore. Okay, this is going to be a lot more helpful with the notations that we've created here. So we're going to sketch the function. But this is a little bit different here. We're actually given some ordered pairs to build off of. So we're going to plot these endpoints. These are kind of giving us starting and ending points, and then we got to kind of fill in the rest of the gap. And this is kind of, we don't have to worry about the y values. We can kind of just make it, as long as we're talking about how the shape is what's most important, right? So maybe your relative max is a different location than my relative min, but we're after the same shape. But we do have some order pairs to kind of help start and stop our problem. And also we have range. So range is telling us at our final product where that the graph is going to display a lowest y value of -7 and display a highest y value of 5. But we'll do this at the very end. Okay, we're going to kind of split this into different stages, right? We're going to kind of build it up from the bare bones, and then we're going to fill in the details. And at the very end, if our graph doesn't display this, then we'll make it extend or shorten it so that our graph, our final picture is going to show these y values as our highest and lowest. Okay, but this we can worry about at the very, very end. But first things first, I'm going to plot these points, and I'm going to sketch a graph that follows the path that I have outlined here. Okay, the graph is going to rise relative max at -1, relative min at 3. Okay. Okay, -5, -4. Okay, 5, 3. Applying those points now. All right, I'm looking at my graph. I want some target points here. I know my graph is going to rise to some point at -3, continue rising, a relative max at -1, relative min at 3. Now, you may be plotting your relative max, relative min in a different location than me, but for me, I'm just going to locate a point that is relatively high on my graph just to give myself a target, and I'm going to pick a point relatively low on my graph for my relative min. But so -1, I'll just choose some random point that is relatively high. At 3, I'll choose a random point that is relatively low. But maybe your point is higher than mine or lower than mine, but it doesn't matter, right? The important thing right now is, can we get our shapes to match? That's what's key. Okay. What I'm really worried about right now is follow the path of these arrows. So I want my graph to be rising to -3, wherever -3 is. Flatten out, continue rising, hit a maximum at -1, decrease, hit a minimum at 3, increase, and then stop at 5. So maybe your order pairs are different from mine, but your shape should match mine. All right, any questions here? So this is the path of the graph, meaning that once we move on to our cleanup stage, we're not going to be adding a completely different location on the graph, right? So everything that we have in front of us is basically the shape of the graph, but we're going to go back and we're going to kind of clean things up. We're going to give it the curvature. We're going to identify the points of inflection. Okay. So next step, I'm going to give myself some target points for my points of inflection so that these are points where the transitions will occur from one concavity to the next. So wherever my graph lands, 3, that's where I'm my point of inflection. So my -3 landed over here, -2 somewhere here, at 1, and then at 4. Okay, so I'm just giving myself some target points. So now all you need to do is to connect the dots, and connect the dots in a way where the curvature is going to continually adapt itself based off of where we are. So we want concave down to begin with. So the first set, I'm going to make that concave down. From -3 to -2, I want it to be concave up. From -2 to 1, concave down all the way to here. Concave up. And the rest of the way, concave down. All right, questions so far? Now let's go back and see if we can answer this part of the question or make it fit this statement. We want the range to extend from -7 to 5. So basically, I want my lowest point to display a y value of -7. I want my highest y value to be 5. So I'm looking at my graph here. So that's my lowest point. So maybe I can just redefine it to make this land at -7. So maybe your graph isn't perfect like mine. It doesn't matter, right? As long as, or maybe you want to erase that and make it extend a little further, you can. But I just want you to show me that you understand how to kind of mold the graph in a way that will match the statement. Okay. We want the highest y value to be 5, and we see the highest y value must be this point. So how's that? All right, how do we feel? Okay so far? Okay. Last part, sketch the second derivative graph. So we're just going to base it off of this information. It's the only thing we're going to look at as we build our second derivative graph. So second derivative graph, we have to understand that our y-axis doesn't represent location. It doesn't represent slope. Now it represents the concavity of the original function. So going to help me remind myself of that. I'm going to label what I'm looking at. Above is concave up, below is concave down. Anything on the x-axis are my points of inflection. And these are going to be where I'm going to be plotting my x-intercepts. So -3, -2, 1, and 4, these all go onto my x-axis. Now, the important thing to recognize is that our graph is not going to match the curvature that we see here. Okay, this is not the original graph, so the graph is not going to display concave down, concave. We've already done that with f of x, right? The shape is going to match here, but now we're just matching location. We want this part of the graph to live in this region below the x-axis. So from -5 to -3, I want my graph to be below, but these kind of act as anchor points. We know the graph has to connect through these points. So from -3 to -2, it's above the x-axis. So we want the graph to go up, but then loop back down. And it's going to kind of keep weaving back and forth between x-axis above and below as we finish this graph here. So from -2 to 1, that's showing below. From 1 to 4 is showing above. And then from 4 on, okay. All right, any questions there? All right, let's do one more. And this is more of a straightforward problem, similar to your quiz. Given the function, let's find the derivative. From the derivative, we can find critical points. From critical points, we can create our sign line. Once we have our critical points, populate our slope sign line. We choose values in each interval. Plug -1 into the derivative factored form. Negative times negative is positive. Plug 1 in. Positive times negative is negative. Plug 3 in. Positive times positive is positive. So now we can make our statements of relative maximum, relative minimum, increase, and decrease. Right? So relative minimum at 2, but if I want to find the location, it's going to the original function. So 2 into the function, I get 2 cubed is 8. 8 minus 12. -4 plus 3 is -1. Relative maximum is 0. Plug 0 into the original function, we get 0 minus 0 plus 3 is 3. Interval increase, interval decrease. Two intervals of increase. Decreasing. All right, that's all the information from our slope sine line. Now we can turn to our second derivative and create that sine line. Set equal to 0, factor out to 6. So the only critical point that we have for our second derivative sine line is a 1. So this is the only potential point of inflection, but there has to be a change in sign, right? Just because f(del prime is equal to 0 doesn't guarantee point of inflection. We gotta test the signs. So I'll test 0, I'll test 2 into my factored form. 0 minus 1 is negative, so concave down. Plug 2 in, positive, concave up. There is a change in sign, so there's a point of inflection at x equals 1. And if I want to find the y value, it goes back into the original function. So I have 1 minus 3 is -2, plus 3 is 1. Concave up, concave down. And then we can sketch our graph. We have some target points. Relative min, relative max, we'll start there. 2, -1, 0, 3, 1, 1. Okay. I know my graph is going to hit a relative max at 0, relative min at 2. I know my the path of the graph is going to be something like this. Our point of inflection is at 1, 1. We know the first part is going to display concave down. And then it's going to switch over to concave up. Okay, any questions? Okay, so this afternoon I'll have a help session at 4. Tomorrow afternoon I'll do go over your quiz. And Wednesday help session, Thursday test. And then on Wednesday, maybe we'll focus a bit more on some of the other optimization problems. We'll kind of review some of the Rolle's theorem, mean value theorem, extreme value theorem. Okay, but at least we've kind of hit the bulk of test material. Okay, any questions? Okay, so again, if you want to be eligible to recover your quiz grade, you need to turn in 2/3 of your assignment by tomorrow night. Okay, I'm not asking for the quiz corrections, but I'm asking for the classwork homework for chapter 3, and also the assignment that the link is in the team's assignment highlights that, and you can just click on that link, and that will take you to that page where the problems are going to be there. All right, so if nothing else, then I hope you guys have a great day. Work on your recovery assignment if you want to do that, and then I'll see you guys on Wednesday.
Mr. Yang?
Yes.
You said, wait, so we do not have school, but you have a help session?
That's right. There's no school tomorrow, but I am having a help session tomorrow at 3. Okay. Right, it's teacher workday tomorrow. But I don't know my schedule, so I may have another help session in the morning once I find something out. But it'll be recorded, so I mean, this is all optional if you want to attend it, but it'll be recorded as well.
Okay, thank you so much. Have a nice day.
Have a nice day, guys. Thank you. See you guys.
Thank you so much.
Thank you. Bye.
Thank you.